is the hand drill. Appearing in the archaeological record over 300,000 years ago, this is the oldest and most fundamental technique, typically consisting of a straight wooden spindle, about 18 to 24 inches long and half an inch thick. The user places the tip of the drill into a small notch on a flat hearth board and spins the wood rapidly between their palms while applying downward pressure. Over time, the friction creates a fine black powder that eventually begins to glow with heat. It requires significant stamina and calloused hands, but it was the primary way early humans mastered fire, using nothing but light materials found on the forest floor. To truly understand the grit of our ancestors, be warned that the average beginner spends about 30 minutes of intense, high-speed scrubbing to produce an ember, burning approximately 250 calories in the process. This means to earn the right to cook a single slice of pepperoni pizza. Today, you would have to successfully rub these sticks together for over an hour. If you manage to spark a flame, you've officially worked off a medium order of French fries. If you just end up with blisters and a sore back, you've barely burned off a single celery stick. Right, I'm a caveman in the comments if you think your palms could survive the friction, or I'll stick to my lighter if you'd rather keep your calories for eating. The fire plow. Most commonly associated with Neolithic coastal and tropical cultures around 10,000 years ago, this method involves rubbing a 12-inch hardwood stick vigorously along a groove in a 2-foot-long soft wooden base. Instead of spinning, the motion is a repetitive, forceful sliding that plows up wood fibers at the end of the channel. As the friction builds, these fibers accumulate into a pile of hot dust that eventually ignites. It is a physically demanding process that depends heavily on selecting the right combination of wood densities to ensure the friction generates heat, rather than just wearing down the tools. The bow drill. Emerging during the Upper Paleolithic period, around 30,000 years ago, this method introduced a mechanical advantage by using a 2-foot-long, flexible bow and a 10-inch spindle. By wrapping a leather cord around the drill and moving the bow back and forth, the user achieves much higher speeds and greater downward force with less physical exhaustion. A bearing block, usually a stone or piece of hardwood weighing about half a pound, is used to press down on the top of the spindle. This tool was a major technological leap, allowing for fire to be made quickly even in damp or difficult conditions. The fire saw, historically utilized throughout the Bronze Age in Southeast Asia and Oceania. This technique uses a sawing motion where a 1-foot section of split bamboo is drawn rapidly across a notched branch. The hollow nature of bamboo makes it an excellent material, as the air trapped inside helps insulate the heat generated during the friction process. As the saw cuts through the fibers, the fine dust falls through a hole into a tinder bundle waiting below. It is particularly effective because the long, rhythmic strokes of the arm are more sustainable than the small, rapid movements required for a hand drill. The pump drill. Developed during the late Neolithic and becoming widespread in ancient Egyptian times, this was a complex evolution using a 15-inch spindle, a crossbar, and a circular flywheel weighing about 1 to 2 pounds to maintain momentum. By pushing the crossbar down, the strings unwind and spin the spindle. When released, the flywheel's weight rewinds the strings in the opposite direction. This creates a continuous, high-speed spinning motion that can be operated with one hand. While more difficult to construct, it represented a sophisticated understanding of physics and allowed for highly efficient fire starting. Percussion flint and pyrite. Dating back at least 50,000 years to early Homo sapiens sites, this method involves striking a 3-inch piece of flint against a similarly sized chunk of iron pyrite. By hitting the stones together, small fragments of the mineral are sheared off and catch fire due to the heat of the impact. These sparks are much cooler and shorter-lived than those created by modern steel, so they required extremely fine, dry tinder to catch. This method was prized because it was less physically taxing than friction methods and could work in freezing environments where wood was too hard to spin. The fire piston. While its exact prehistoric origins are debated, This device was documented in ancient indigenous cultures of the Malay Peninsula long before its European discovery. It consists of a 4 to 6 inch hollow cylinder and a tightly fitting piston made of wood, bone, or horn. When the piston is slammed quickly into the cylinder, the air inside is compressed so fast that the temperature spikes to over 500 F, high enough to ignite a small piece of tinder at the tip. It is essentially a prehistoric version of compression ignition, showing a remarkable grasp of thermodynamics using only simple natural materials, the fire piston. This device is nothing short of a mechanical masterpiece and a brilliant leap in prehistoric engineering. While other methods rely on raw friction and muscle endurance, the fire piston utilizes adiabatic compression, the same high-level physics found in modern diesel engines. To a fabricator, the most impressive part is the precision required. For this to work, the piston must have a near-perfect airtight seal, likely achieved by ancient craftsmen through meticulous sanding and the use of natural lubricants like animal fat. It is the ultimate low-tech, high-science tool, proving that even without metal lathes, digital sensors, early engineers understood how to manipulate air pressure to create a self-contained, instant ignition system. It is, quite literally, the world's first internal combustion component. If you're still watching, it means you've officially survived a crash course in prehistoric survival without actually getting a single blister, which is a huge win for everyone involved. Since this channel is still in its infant stage, kind of like a baby mammoth, but with less fur. I'd love to know if you want more of these deep dives into the weird and wonderful ways our ancestors stayed alive. Drop a comment below with your best prehistoric life hack, or tell me what topic we should tackle next. If you don't comment, I'll assume you are currently stuck in a cave, somewhere trying to rub two sticks together. Don't be that guy. Hit the like button, subscribe, and let me know you're here so we can keep building this fire together.